So welcome to Data Cleaning with Python and Pandas. My name is Matt Steele. I am a research engagement librarian here at WVU. I'm joined along with Jeff Worth, who is a science-based instruction librarian at the university. I will be leading this presentation, but this is intended to be a hands-on demonstration for you guys, and um, it's an introductory workshop. So if you have any questions while this is going on, please feel free to unmute and ask your question or ask it in chat, and we'll be happy to help you out if you're having any technical difficulties. Ask your question through chat either directly to Jeff or to everyone. One piece of business we have to take care of before we get started. This is my fault, my apologies. I accidentally set the repository for the lesson plan to private. So what we're going to do to start off with is we are going to go ahead and download the lesson plan for this workshop. I'm going to go ahead and I'm going to put the link to the lesson plan in chat. You can add your lesson plan in one of two ways. You can either go ahead, open up GitHub Desktop, which you were asked to download for this session, go into File, Clone Repository, and then click on URL, and you'll paste the repository link that is in chat into the URL. You can then choose where on your computer you would like to store this file by clicking on the Choose button. Once you've done that, go ahead and hit the Clone button, and you'll be able to, and it will download the files for you. Your other option, if you do not have GitHub Desktop, is you can go to that link that is in chat, and here at the code box, click on Code and download the zip. When you've downloaded the zip, you'll go ahead, it'll download as a zip file, so you'll go ahead and open it, and you'll extract it, and you'll choose where on your computer you want to save the files to. Once you've done that, just note where the files are saved to. When you're ready to move forward, you can go ahead and raise your hand once you've gotten your lesson plans downloaded. And I'll give you a second to do that. And I'll kind of work on talking through the agenda while you guys are doing that. So a couple of things, just to as a reminder, when you are learning a programming language, programming languages, one of the things that they don't really provide for you in much detail are here's how you do things. Here's what commands are available to you. Here's how you run them. Where they put this information is in their documentation. So either the standard Python library documentation, or for this workshop, we're going to be using a add-on package or an add-on library that is called Pandas. So one thing I really suggest as you start to use these various programs is to really use their documentation to understand what you can do for it. Pandas actually has a great one. So they actually have a getting started guide that you can go through, as well as a user guide. And then all the functions that will be available to you will be available in this API reference tab. So you can see everything that is available to you and how you run these functions in the AP reference tab. Another thing that the library has available to you is a database that is called the O'Reilly Learning Platform. And the O'Reilly Learning Platform allows you to have a place where you can develop soft skills. So for instance, if you are interested in using Python for data analysis, there's the Python Data Analysis book, third edition, that you can go through and you can look through, and they have lesson plans that are pretty easy to use and built-in exercises within it. So not only are you reading about it, but you are also running exercises based on it. In addition to that, they also have courses and videos that you can use. That looks like the book again. So they also have courses, videos, audiobooks, and so on for learning these things. These courses are typically about 10 minutes long. Or I'm sorry, these courses are typically longer courses, but each section for it, if you look through these sections here, are broken down into manageable bites, somewhere between 3 and 10 minutes long. And again, they also provide exercises for you as well. So not only are you learning about it, but you are also then applying what you have learned in exercises. Okay, how are we doing with downloading the lesson plan? Any thumbs up or hands up for being able to get it done? Great. Okay, so what we are going to do today is we are going to start by discussing how you enter data into Python. You can do this through a variety of ways: lists, dictionaries, series, and data frames. We're going to then also talk about reading or importing data into Python, cleaning that data and exporting that data, as well as doing some very simple analysis on the data. We'll also look at exploring the data and the data frame and what's going on with it. So just a quick recap, if you were at the first session or if you were not at the first session, in Python, using programming languages of all sorts, the way you give commands is you will type in functions, the name of a function, a built-in function into it. Uh, Standard Python library has a bunch of built-in functions, as well as any add-on library that you add to Python will increase the number of built-in functions that you have available to you. You can also create your own functions within Python. So if you want to create a operation of some sort, you can do that by creating a function. Within functions, then you have arguments. So arguments will tell the function how to run, right? If you have a function where you want to filter out a variable, the arguments within that function will say, here's the variable conditions that I want it to meet. Additionally, you have what are called variables in Python, and variables allow you to store information of some sort. This information can be a one-dimensional array, such as a list. It could be a data frame. It could be an operation. It could be a number or a value. So some sort of information you can store into variables that are then easily recalled and easily worked on. And then just a quick reminder that before anything happens, you do have to run the code that you have typed in. So the act of typing it in is not enough. You actually have to physically run that code before anything changes on your computer. So let's go ahead and let's get started. On your own computer, open up Anaconda or the Anaconda Navigator. And once you have that open, then go ahead and launch Jupyter Lab. And Jupyter Lab will open up in your default browser. So once Jupyter Lab opens up, you will just need to start a new notebook with a Python 3 IPy So go ahead and click on that, and it should start a new file for you. Okay. Once we get Jupyter Lab opened up, then we can go ahead and get started. So that we're going to start today with talking about how you enter data into Python. The way you enter data in usually is through a one-dimensional array. And there are different ways that you can enter these one-dimensional arrays or sequences into Python. The most common one is your list. So if I create a new variable and I call it example list, you can enter a list using the brackets. And then anything in the list, you'll separate by comments. One thing to understand about the list is that all the values have to be of the same data value type. So if you are entering in a numeric number, the rest of them have to be numeric. If you are entering in a string variable, the rest of them have to be string. Once we run that line of code by either pressing the play button or hitting Control Enter on a PC or Command Return um, on a Mac, it will save the list into your environment. We can call the list then at any time by typing in the name of it. The other way you can call an object or a variable, I'm sorry, is by using the print function. Oh, use use straight brackets instead of parentheses. Okay, so those are the ways that you can call then the data that you've entered in. Now, with this information, when I say a one-dimensional array, what I mean is a sequence of information. And so if you think about if you're used to spreadsheets, either Excel or SPSS or Stata or something like that, when we say the one-dimensional array of information, I mean either one-dimensional horizontal or one-dimensional vertical. And this list we just created, essentially what we did is the same thing that we are looking at in this Excel file. We are just using these commas to essentially break out the sequence of numbers, or the sequence of information into essentially cells. So go ahead and on your own computer, create a list. Again, the syntax for creating a list is we'll create the name of a variable. And this one we did example list. You use the equal sign to create the variable, and then you use straight brackets to create your list. And you separate anything in your list with commas. So go ahead and on your computer, follow that and go ahead and create a list of your own. And when you're ready to move along, go ahead and raise your hand. How are we doing? Or do we need more time with the list? Or are people ready to move on? Okay, let's go ahead and move on. Okay, so one thing about lists are mutable, which means you can change, add, or remove items from the list after the fact. They are ordered, so there is an order to this list. In it, one comes first, two comes second, three comes third, four comes fourth. And then it can be indexed, so you can ask where something resides within the list. There are other types of sequences that you can also create in Python. There is tuples, and you create tuples using parentheses. So example tuple will equal 1, 2, 3, 4. The difference between tuples and lists are, while both of them are both ordered, tuples are unchangeable. So once you put a tuple in, that is set in stone and you cannot change it. There is also sets. So sets are unordered, unchangeable, and unindexed. So you can create those through the curly brackets. The order doesn't matter within them, but you cannot change it and you cannot index it. So you cannot ask where something sits within it because obviously it's unordered. And then finally, there's a dictionary. So a dictionary is like a list, but you can actually give a value or a key to each value that you put in. So one thing we can do with that is we can create a new variable and we'll just call it, country roads um and we create a dictionary with curly brackets and then we have the key first and then the value second. So we have key one, value two, key two, value two, key three, value three, key four, value four. So if we wanted to go ahead and create an array where we have the names of West Virginia towns and their population, we can do that with a dictionary entry. So this is you can still think of it as one dimensional, right? These are the values that we have in there, but we're just also adding a key to each one of these. So go ahead and on your computer, try out putting in a dictionary. You can do this however you want to. You can do it with the country roads example that we have on there. If you want to try your own, you can do that as well. Just the first entry needs to be the key, and the second entry needs to be the value. And when you're ready to move on, go ahead and either give a thumbs up or raise your hand in chat. Or not in chat, in Zoom. And if you have any questions during these breaks, please feel free to ask either in chat or by unmuting. Okay, next thing we're going to talk about then is adding libraries to your environment in Python. So when you download and run Python, you get what is called a base library that comes with it. This base library includes a lot of built-in functions that allow you to run things. However, because Python is open source, people are allowed to create what are called add-ons or libraries or packages. And these packages will allow you to have more functionality added to your Python environment. There are some big ones to use with if you're interested in using data science for Python. Some big ones for storage manipulation and calculations are NumPy, Pandas, SciPy, and stat models. We're going to be looking specifically at Pandas today. For visualization, there's Matplotlib, there's also Seaborn, which I don't have listed, and there's Bokeh. Then if you are interested in machine learning, you have Scikit, TensorFlow, and Keras. So what we're going to do next is we're going to add in the package Pythons into our environment. Now, anytime you exit a session of either Jupyter Labs, or you end a kernel or restart a kernel, what that does will end your session. And every time you end your session, any of these add-on libraries that you have will become unloaded. So every time you start a new session, you do need to recall these add-on libraries or packages. And the way you do that in Python is using the import function. So you'll put in import and the name of the add-on library that you want to add. So in this case, we're going to add in pandas. Now, one thing about using functions from libraries in Python is that usually what you'll need to do is you'll need to denote in your code the package that you are running the function from. And you do that by just putting in the name. We'll look at some example functions for doing this. But one thing that you'll do is you'll be typing this name over and over. So to save yourself some time, what Python allows you to do is import the libraries as an alias. And this alias can be anything that you want to call it. There are some standard conventions for doing it. Typically, when you import pandas, you use the alias PD. So that way, if you're looking at other people's code and you see PD dot something, you know that they're running a function from the pandas library. So we're going to go ahead and import pandas as PD, and that will give us the functionality that is available to us through the pandas library. So go ahead and on your computer, import pandas as PD and run that line of code. I'll give you a couple of seconds and then we'll go ahead and move along from there. The other thing I'm so sorry, I forgot to mention, make sure that when you open up Jupyter Labs, over here you are in the folder for the lesson that we just downloaded. So we are in the data cleaning workshop, and you should have these files within it. Okay. Similar to dictionaries and standard Python, in Pandas, we have what is called a series. And a series allows you to create arrays with these key values attached to them. And it also allows you to name the array. So we can create a new series. We're going to call this example series. And then to call or to create a series within it, we're going to use the function pd.series. So this pd dot is saying to Python, hey, from the pandas package that we've given the alias to as pd, use the function series. And then you'll do parentheses, you'll do the values within straight brackets, and then we'll set the index. The index will be the value or the keys for it. So if I do example series equals parentheses, straight brackets, 1, 2, 3, 4, straight brackets. Um, and then we'll do index equals A, B, C, D. And then you can also give it a name. Name equals example.
You forgot the PD dot series.
Oh, thank you. So now we've created a one-dimensional array where it's got the values 1, 2, 3, 4 installed. One has an index of A, B, or two has an index of B, three has an index of C, four has an index of D, and the name of the series is called example. And then you can also see that it has a data type that is an integer. So these are integers, right? Because these are the values, not the index. The index is just a label for the values. So go ahead and try and create your own series. You can do it with the numbers provided, or you can try out your own numbers. And once you're ready to move along, go ahead and raise your hand. As you're kind of working on this, I'll talk a little bit about the index too. The index is not necessary to put into a series. It's something that you can put into it. And you can kind of think about it, if anybody's ever used SPSS before, you can have a variable, and this is usually particular to categorical variables. You can have a variable and it's got a value to it, 0 through 5. Think of like a Likert scale one, 0 to 5. The label for it, that value then would be, 0 is disagree, 1 is somewhat disagree, 2 is, you know, kind of disagree, or however they go, 0, or, whatever is 3 is neutral, so on and so forth. So that's this index is kind of like that Likert scale part of it, that you can assign a label to the value. So again, the index is an optional portion that does not have to be in there, but can be in there. Okay, once you have your series created, the next thing we're going to talk about then is how do you create a data frame. So the data frame will be the two-dimensional, size mutable, heterogeneous tabular data structure. So what that essentially means is it's two dimensions. So if we think back to our Excel spreadsheet, it'll be both vertical and horizontal, right? Your typical table, our data frame. And then heterogeneous means that it can have observations within it that have a mix of integers, string variables, categorical variables, so on and so forth. Within the variables themselves, the variables have to be the same data type, but an observation can have multiple data types within it. Within data frames, variables are the columns and they represent the data types. And observations are the rows where they represent the individual entries. For each variable in a data frame, like I said, there's typically that data within it needs to be the same type. So if the variable has observations that are integers, all the observations within that variable should be integers. However, different variables can combine different data types. So one could be an integer, maybe you have a variable that's a year and you have a variable that's a rating and a variable that's a title or something to that nature. To create a data frame, we first have to start by creating we first have to start off by creating series. So in this example, we're going to create 4 series. We're going to create one for year, one for title, one for length, and one for gross. I'm going to go ahead and just copy that. And I will go ahead and I will post this into the chat so you can easily copy it and put in so we're not worried about writing up too much. So this first one is creating a variable called year. And then we use PD series to create the series. And we have 3 entries, 1977, 1980, 1983. And we're going to give this series the name year. Same thing with this title. We're going to put the titles of the movie in, and we're going to put in title. Now, when we put these together in the data frame, the order of the series matters. So this observation, or this is going to be observation number 1 in year. This is going to be observation number 1 in title. This is going to be observation number 1 in length. And this is going to be observation number 1 in gross. So these will be the first observation, these will be the second observation, these will be the third observation. So the order does matter, the size also matters. So if one of these is a series that has 4 sequences in it, it will not fit into the data frame because the other series have 3 in it. So the series all have to be the same size. Once we have our series set up, though, we'll go ahead and run that. And then we can put together the series into our own data frame by using the function PD data frame from Python. So if I go ahead and copy that and I'll put that into chat, and then I run that. So here we're creating a new variable. We're calling it Star Wars underscore data frame. We're using the PD data frame to create the data frame. And then we're saying the year, we're going to grab the year, we're going to grab the title, we're going to grab the length, and we're going to grab the gross. And giving it this name means that it'll link those together. And if we go ahead and run that and then print it, we can see we've created a data frame. The first observation is 1977. Star Wars for the title, 121 for the length, and 787 for the gross. So go ahead and try that out in your own environment. If you have any questions, please let me know. If you're ready to move along, please go ahead and raise your hand. Okay.
I had a
Once we have a
question.
data frame, either if we load the data or create our own data frame, we can then start subsetting the data frame. So subsetting means working, either looking at or working with specific variables or columns from the data frame. And we subset a data frame, a variable within a data frame, by typing in the name of the data frame, the variable that we have it stored in, and then in straight brackets, the name of the variable that we want to look at. So if I run this line of code, it'll let me look at what are the titles, what is going on with the title variable. We get the name of it and the data type for it. We can also within this get things like we can also within this get things like, well, what is the mean of a particular variable within it? So if I do,
Matt, before we get too much further, it looks like we have a question.
yes,
Oh, Chandra had your hand up.
Yeah,
Wasn't sure.
I'm sorry. I don't mean to distract, and maybe you could take the question at the end. But my question was for both pd.series as well as pd.dataframe. Is there, I know I can go to the documentation to see what arguments are available, right? Like series has index and name. Is there anything I can do programmatically to discover? Like if I just do pd.series, will Python give me or pandas give me what arguments are available in series? Same
um,
question for data frame is not only the arguments, but does pandas tell you that give you any help on the errors, whether the length is wrong or number of what is wrong with the data? Okay,
yeah,
just to help.
yeah,
So this gives you documentation.
yep.
Okay. All right. Thank you.
You're welcome. So again, then we can also run functions on subsetted variables. So if I wanted to get the mean of the length of the average movies, then we can see that the average original trilogy was about 129 minutes with a repeating set. So big takeaway here is once you have a data frame, if you want to subset a variable, we use the straight bracket and the name of the variable within quotation marks. And you can see it can either be single quotation or double quotation. It does not matter. The other thing then too is once we have a data set created in Python, it does not save to your computer until you tell it to save to your computer. To do that, we use the .to_CSV function. So we type in the name of the data, the name of the variable we have the data set saved into. And then we do .to_CSV, right? And underscore CSV. And then the name of the file, whatever we want it to be. So this can be a brand new file and the extension for the file. So we're going to do a .csv in quotation marks, and then we're just going to say that there is no index. So we're going to say index equals false. And then when we run that line of code, we will then get a new file within our working directory that we just exported. A lot of the time, though, we're not going to be usually creating our data within it. We can create our data within it, obviously, as we showed, but a lot of the time what we're doing is reading data or importing data into Python. And there are lots of ways that we can read it. The most standard way you'll do, most files that you'll come across usually are a CSV file, a non-proprietary comma delimited file or comma separated file. But there are also various other ways that we can load it in. We have, if you are reading, if somebody's file that you have is an Excel file, you can use the read underscore Excel file. If you are working with somebody who is using proprietary software like SAS, SPSS, or Stata, there's read SAS, read SPSS, read Stata, and then if you come across XML or JSON files or HTML files, those are also readable into Python. So the first one we're going to read into there is a non-proprietary file. So non-proprietary files, like CSV, are formats that can be open and used in any software platform. So it doesn't matter if you're using Excel, Python, R, SAS, Data, whatever you're using, you can read a CSV file into it. And it just stands for a comma-separated file. They're just files stored in plain text format, where the values are separated by the commas, kind of like how we did when we created our series. So to read a CSV file in there, you do have to have pandas loaded up, which we do. And we're going to create a new variable. We're going to call it reviews. And then we are going to use the pd dot read underscore CSV. One thing I will note, and this kind of goes back to somebody's question on it, how do you know what is available to you? So I started typing in pd dot. And after I hit the PD dot, I hit the tab button on my keyboard. So tab either on Mac or on PC will open up an auto suggest menu for you. Then if I start typing read, I can see that I've read CSV, read Excel, all those functions we just talked about. So I'm going to do read CSV, then I'm going to do the quotation marks, or I'm going to do the parentheses. And then we're just going to put in the name of the file that we want to read in there. So we're going to read this file, customersreviews.csv. So if I put quotation marks and I hit tab again and I start typing in customer, we can see we have customer reviews.csv, and then we'll just close that up and we'll go ahead and run that line of code. And then we'll type in reviews and we'll be able to see the data frame we just loaded in. So go ahead and on your computer, let's go ahead and load up this reviews data set that you have. And when you're ready to move ahead, go ahead and raise your hand. Okay. In addition to reading non-proprietary files, Python also gives you the ability to read proprietary data into it, read proprietary files. So proprietary files SPSS is their .sav file. SATA has their .dta file. SAS has their .sas file. These are proprietary files that are only designed to be open with the program that's loading it. Think about the same way, Microsoft Word files are really only designed to be opened up with Microsoft Word documents. Same thing with pages from Mac. They're only really designed to be opened up in a Mac. However, Python will allow you to open up these files within it, just using the read and the name of the program that you want to open up. So within our file, we have a .sav file that's called demographics.sav. And if we wanted to load that up, we would just need to create a new variable. I'm going to call it demographics. And we're going to say equal pd.read_spss. And then in quotation marks, the name of the file we want to load, demographics.sav. And then we'll just call it afterwards just to see that our final thing worked out. So it went ahead and it loaded up this file for us. So go ahead and on your own computer, using the read SPSS function, let's go ahead and load up the demographics SAV. And when you're ready to move along, go ahead and raise your hand. If you have any questions about this, please let me know. Okay. So one thing that you may want to know then is, well, what is exactly is going on in my environment? So we've loaded up a couple of data frames. We have some variables saved. We have an add-on package or library loaded up. And there's nowhere really in Jupyter Notebooks that says what is going on within your own environment that you've loaded during your current session. We can, however, see that using the command %whos. So this will tell you what is going on in your particular environment. So if I do %whos, and I run that line of code, we can see we've created a dictionary called country roads. We have a data frame loaded up that is called demographics, and it has 64,000 observations and 29 variables. We've created a list. We've created a series. We've loaded up the Pandas library, and we've noted that its alias is PD. We've got our Star Wars data frame. We have our reviews data frame. So this is a way to see in your current environment what is going on. All right, once we have a data frame up, then we can do a bunch of things to explore what is actually going on in the data frame. There's the heads and tails. So if I call up my data frame reviews, and I say data frame reviews head, it'll give me the first 5 entries within it. You can change that, so you could say head 10, and you would get the first 10 entries within it. You could also say the reverse, the tail, and you could get the bottom of it. There's also, you could see what types of values are going on in the data frame with the D types. So what data types are within it. So if I run reviews.data types, I can see I have clothing ID and it's been distinguished as an integer, age as an integer, title as an object, review text as an object, so on and so forth. I can see the info on it. This will provide a summary of the data frame, such as the number of rows, columns, and data types. So it's a little bit more granular of the D types. So I have clothing ID. It's got 23,000 entries. There are no null values in it, and it's an integer. I can see the shape of it, which will give me oh, no, which will just give me the dimensions of it. So this data frame has 23,486 observations on 10 variables. I can get what are the names of the columns. So what are the variable names within it? And then I can get some basic descriptive statistics about it with the describe. So if there are numeric values within it, it'll grab the descriptive statistics of it. And finally, if I have a categorical variable in there, or if I have a variable that has repeating entries within it or duplicate entries, I can find that out with reviews. So we'll just do the subset and we'll just grab the variable class name. And then it'll be dot and value underscore count. So within the variable class name, there's 6,000 entries for dresses, there's 4,000 entries for knits, there are 3,000 entries for blouses, so on and so forth. So go ahead and in your Jupyter Pi, try out some of these exploration tactics that you have available to you. I'll give you a couple of minutes and then we can go ahead and move along. If you have any questions, feel free to unmute or ask in the chat. Okay, let's go ahead and move on. So another thing that you can also do within your data frame is start to get some descriptive statistics about your data frame. So the first one we're going to get is the count. So if I look at reviews and then I do count, and I run that, you can get within it the number of observations within each variable. So we can see right now in title and in review text, it looks like we'll probably have some missing some missing data. The other thing you can get is the first and last items in it. So if I go into age, so we're going to subset the variable age in the reviews data set, and I go to first. Hmm. So without parentheses. So we can get the first and the last. And then if we are looking for the mean, we can grab the mean of that particular variable. Likewise, we can get the median. We can also do things like get the minimum value. So the youngest age within this data set is 18. The oldest age within it will be 99. And we can get things like the standard deviation and the variance within it as well. And then if you want to grab the sum of a particular variable, you can also grab the sum of it. So go ahead and try out these. You can try it out on the age variable. Most of them will require a numeric or an integer. So you could grab rating if you want to get rating instead of age. But go ahead and try out these on your own computer. If you have any questions, feel free to unmute, and we'll move along in a couple of minutes then. Okay, let's go ahead and move along. The next thing we're going to talk about is functions available to you for cleaning your data. And you may ask, well, why do I need to clean a data? There's lots of reasons for it. The data in the columns or rows might not be ordered in the correct way. You may need to create values or ignore missing data. The units are not correct or off in some way. The order of magnitude is off. You may need to create new variables using current observations, or change the type of the type of data within a variable. Or there might be outliers or skewing of the data that is going on. So the first function we're going to talk about for cleaning your data is the filter function. The filter function allows you to select observations in your data frame that meet a certain condition within a variable. So right now, if we look at our reviews data set and we go over here, we have the division name, division class, class name, these ones right here that are pretty much a categorical variable within it. And let's say we want to go in here and we wanted to filter out our data frame. So we were only seeing observations that met the criteria in the division name for the general division. So only people that bought from the division general within it. We can do that with the filter function. So to do that, we're going to create a new variable. We're going to call it reviews underscore filter. And then we're going to say reviews and straight brackets. And then in this, we're going to put our filter function. So reviews, division name, so the name of the variable, division name, and then equal, and then the name of how we want it to, or what we want to filter to. And then we'll close that up with another straight bracket. So some things about this is the variable name has to be identical to the variable name. So capital D, capital N. And the name has to be exactly how it is spelled and the case sensitive within the data frame. So capital G general. And if we run that and then call the reviews filter data frame, you can see now that the division name has just been filtered to only observations that meet the criteria that we set. So we've gone from 23,000 observations down to 13,000 observations. So throughout 10,000 observations within it. Now we use Boolean operators in this to tell the criteria that we want to set it to. So we use the equal one for it. So we wanted these observations to equal general within division name. You could also have said not equal. So if we said not equal general, and then we run it, we'll get everything but general within the division name. So about 9,000 observations within it. If we're working with numeric numbers, we could use the less than, greater than, less than or equal to, or greater than or equal to signs for a Boolean. In addition, we can also link these together so we can set more than one criteria for it. So in this example, we're going to add in both criteria need to be met here. So both the division name must be general and the age of the person must be less than 40. So we're looking at people under 40 who are buying from the general division. One thing too is as you're looking through your code, if you click on a bracket, so what I did last time is I had this closed and that was not correct. So that was closing this thought. So if you click on a bracket, you can see the close bracket or the starter bracket within. So if I run this line of code down, So if I run this now we are getting only people who are under 34 who has shopped in the general section. So go ahead and try out some filters on your own. I would suggest just starting it off with one filter. You can do anything you want to within the data set, or if you wanted to use the division name example, you can try that out for yourself. If you have any questions, please feel free to unmute or ask in the chat, and we'll move along in a couple of minutes. Okay, let's move along. And the next thing we're going to talk about is how do you select particular variables in a data frame. So let's say you have a data frame and you don't need all the variables within it for whatever reason. So if I look at my reviews data set and I ask it what columns are available to me using the reviews.columns that we talked about during the explore. So we see we have clothing ID, age, title, review text, rating, so on and so forth. I can actually select out particular variables. So I'm going to create a new variable. I'm going to call it review select. I'm going to say that equals reviews. And then straight bracket, straight bracket. And I'm just going to select certain ones. So let's just grab age, title, division name, and department name and class name. And close that up. And then reviews. So what that did is it just selected the particular variables that I wanted to be in the data frame, and it threw the other ones out. Now, one thing that is important to note about this is we gave our variable a new name. We gave it reviews underscore select. If I were to give it the reviews name that we have our data set, our raw data set stored in, it will overwrite that. So it will throw those variables out and we'd have to go back up to our read CSV code to rerun it and to get those variables back. So whatever the last operation you ran on a variable will overwrite it. So just be very careful when you are creating variables. That if you are doing things like discarding information, you may want to put that in a new variable or store it into a new variable. But go ahead and try out the select option. And if you have any questions, let me know, and we can move along in a couple minutes after you try that out. Okay. Let's go ahead and move on. Next one we're going to talk about is a big one. It is the assign function. The assign function allows you to create new variables in your data or change existing variables by performing calculations or transformations on currently available observations within your data set. So if I pull up my demographics data set, we can see that we have an income variable, and all of the income within it are within the thousands. But let's say we want to see it as a cleaner set. We kind of already know that it's in the thousands, so we want to just basically see it within without the three zeros. We've deemed it unnecessary. So what we're going to do is we are going to overwrite our current variable. So we're going to call it demographics, and we're going to say demographics dot the assign function. And then the parameters within that are, first we're going to put in the variable we want to change, or the new variable, either the variable we want to create or the variable we want to create, or if we call it a name. So if you call it a name that already exists in the data set, it's going to overwrite that. So right now we are going to overwrite it. If you call it something new that doesn't exist in it, it will create a new variable and it will append it to the end of it. So for this, we're just going to overwrite it though, and we're going to say the variable demographics, or the variable income in the demographics data set, is going to equal the variable income, spell it right, divided by 1,000. I'm going to close that up and close that up, and then call the demographics again. So if I run that, now the income variable has all been divided by 1,000. So assign is a really powerful function within it. It allows you to take current observations and use them to either create new variables or to overwrite variables already within it. So go ahead and in your own environment, try out running the demographics, the assign function within the demographics, and see what you get. And we will come back in a minute or so after that. If you have any questions, feel free to ask in chat or to unmute. Okay. So building on the assign function, we can also use this to recode values within it. So if I look in my data set right now for the reviews, we have a variable within it that says basically recommend to an individual. We ask the value counts, and right now it's only got ones and zeros within it. So the assumption here is one is going to mean yes, I would recommend it. Zero is going to be no, I would not recommend it. Usually when you are working with a data set that has values such as this, you would have a code book to tell you, okay, 1 means this, 0 means that. With this, we're just going to run on a recommendation. Let's say we want to change that into an actual value label. So what we are going to do here is we're going to update the reviews variable that we already have in there. So we're going to overwrite it here. We're then going to use the reviews.assign function, and we're going to create a new variable that is called recommended recode. And we're going to have that equal reviews subsetted the recommended ID. And then we're going to add on to that the map function from Python. So map will say, map these particular things to something. So we're going to, within that, say 0 is going to now equal no. I would not recommend it to an individual. And 1 is going to now equal yes, I would recommend that to an individual. And we're going to close up the curly brackets, and we're going to close up, yeah, the apostrophes. And then we're going to check out the reviews. Uh, okay. So now what we have here is we have a new variable created within our data set that is called recommended recode. And every time it saw a 1, it changed it to a yes. And every time it saw a no, it changed it to it changed it into a no. We can also just overwrite our current one. So what this one is saying here is with the instead of the dot map, we're doing a dot replace, and we're replacing 1 and 0 with yes and no. So both of these work. This is an overwrite, and this is a create new variable. Similar to that, we can also recode data values. So if I grab reviews.d types and run that line of code, we can see we've got this clothing ID variable within it that it's interpreting as an integer, when it really looks like it's an ID number for it. So if we want to change that from an integer into a string variable, we can do that by using the as type function from Python. So we're going to say as type and turn this into a string variable, and we're going to run that, and then we'll run reviews d type again. And d types. So now that has changed from an integer into an object. So another thing that we can do with it then is we can also change the value of it. We can do that as category, as numeric, as integer, whatever you need to change it into. We're going to skip a little bit of it because we are running short on time, but you can look through, if you want to rename a variable, if you want to move a variable to where it is in the location, or if you want to sort variables, you can also do that. Next thing we're going to look at though is, hey, I have a categorical variable within my data set. How do I the group by function within that will allow you to group similar observations with it and grab some descriptive statistics on it. So if I was looking in the class name variable, for each observation, it will group all the observations together and it'll grab a descriptive statistic. In this one, we're grabbing the mean. You could grab the sum, the standard deviation, whatever you are looking for within it. You can either do that by a singular observation or by doing an aggregate by using the .agg function within it. So this will grab the mean, the min, the max, so on for it. So if you want to grab more than one descriptive statistic, and this is actually grabbing more than one descriptive statistics on two variables, both rating and positive feedback, you can do that. And then if you are working with missing data, you have a couple of options for missing data. The first one is the drop NAs. Yeah, that's all right. So if I'm looking through my data set, I can do the is NA to see it combined with the sum to see within each variable if I'm missing any NA variables. So in title, I've got about 3,000 missing ones. With that, then you can use the drop NA to remove all missing variables from the data set. So if I run that again, we don't have any missing variables. But if I look at the shape of it, we have a much smaller data frame than we were working with because no matter what, if an observation has an NA in it, it will be removed. So all 3,000 from that title were removed. The complete observation was removed. The other thing that you could do then would be a replace or a fill NA. So if you don't want to remove them, you can just fill it. So if I look in the titles, what's happening with the title is the person probably just did not give a title to their review. So we could just change that around and we could just say, instead of removing it, just give it a new title that is none given. So now anytime that there was an NA value within there, it is now just a none given. And then the final thing that we can do once we are all done, similar to what I was talking about with entering data, is nothing changes on your computer while you are working on it in your Python environment until you actually export it, like you are using the save file. And the save file in Python is your two CSV files. So we are going to export our reviews and we're going to put it in a file named reviews.csv. If I go ahead and run that line of code, I will now have a new file within it that is the cleaned reviews.csv file. And then we can come back to that at any time and we can load it up or we can give it to somebody or we can use it for further data analysis. Okay, so that is an introduction to cleaning data using Python, cleaning, entering, importing, all that fun stuff with data. Are there any questions on this? If there are no questions, you are free to leave. It is 5 o'clock. I will stick around if there are any questions. If not, have a good day. Thanks, Jeff.